Okay, we're up to the third lesson in graphs and networks, and you had Mr. Co yesterday, and you're back to me. So we're looking at, today we're going to look at a special path and circuit called Eularian. If you pronounce Eularian as like oil, O-I-L, Eularian path, not Eularian. Anyway, so we're looking at a few words again. So paths, it says path is a series of vertices connected by edges, and a circuit is a path that starts and finishes at the same vertex. You don't need to copy that down because you already had it from the last time I saw you. So here's an example of a connected graph. We've got A, B, C, D, E. So an example of a path is A, B, D. So we're just going from A to B to D. That's a path. And I went too far. Sorry, guys. And another example of a path could be from C to D, up to A, across to B, down to D, across to E. So we've got a path. But the question is, can you make a circuit? Oh, gone too far again. Sorry about that. So, can you make a circuit? Can you get back to the same spot? You could, as long as you don't use all the paths. So, a circuit, C, A, B, D, C. We've made a circuit. We haven't gone to all the vertices. But that's not important at this stage. Okay, so if you need to copy that down, have a go. And okay, so we're just going to go on to special types of circuits and paths now. So an Eularian path is a path that uses each edge in a graph only once, but you can go back to a vertex. So for instance, if we start at A, go down to D, across to C, up to A, across to B, down to D, and then finally finish at E, we used every path once. We went through A twice, but we've used every path once. And there are other paths as well. But at this stage, if you want to copy that down, please do so. So let's look and see if there's any other paths. So if I just... Okay, so we're looking just if there's any other Eularian paths. We could have started E, gone up to B, crossed to A, down to D, gone back to C, and finished at A, and we would have had another Eularian path. So there's lots of Eularian paths in this particular case. So moving on to the next slide. So we're using the word circuit this time, and an Eularian circuit. We've got to use an Eularian path that can go along every edge only once, but this time you have to start and finish at the same vertex. So looking at this particular graph, which is a new graph, if we look at starting at E, go up to C, go across to A, up to B, down to C, across to D, finishing at E. So I think there's a letter missing there. So I've gone B, C. I think we need to put another letter in just there. So I'll put the letter D in. D was missing. So DE starts and finishes at E, and we've used every edge only once. So could you please copy that down? So we've got two new words, Eularian paths, Eularian circuits, where you're using each edge only once. So for instance, if you were delivering the mail, you only want to go along the roads once, or if you're picking up garbage, you only want to go along the roads once. Or bus timetable, hopefully. Okay, so in this particular graph, we've got a new network, A, B, C, D, E. We've had this one before in terms of the shape, but can we make an Eularian circuit from this graph? Why or why not? Have a think about it, and when you're ready, come back to me. You would have seen that we've got problems with E. E is by itself stuck out there, and if we're going to get a circuit, we've got to get either from E and then back to E, or E has to be included somewhere, and which means that this particular edge would have to be used twice. So in this particular case, no, we can't get we can't get a circuit. So it makes sense. And again, in the next slide or two, we're going to show you how you can predict if there's a path or a circuit. So when you're ready, if you want to make that note, and when you're ready, come back to me. Okay, you're back again, and we're moving on to the next slide. So there's some mathematicians been working hard on undirected net graphs, and they came up with a few notes about Eularian paths and Eularian circuits that I think that you would love to have in your cheat sheet for the test, because these are stock standard. So if we're going to have an Eularian path, we can have odd degree vertices, but you can have none of them or two of them, and that's the only way it'll work. So you can have odd degree vertices, which is what Mr. Coe taught in the last lesson, and I taught in the first lesson, but you can only have none of them or two of them. But for an Eularian circuit, the last one, you can have no odd degrees, absolutely none. So for an Eularian path, you can have none or two, but to make a circuit, you're not allowed to have any odd degree vertices at all. Suggest you put that in your cheat sheet and lock it away, because that's gold. So I think now we're moving on to an exercise. So exercise 21C on page 170 will give you plenty of practice on Eularian paths and Eularian circuits. And in next week's classes, we're going to look at some other interesting circuits and networks and get on to directed graphs and networks as well. So thanks for coming. See you next time.